Hello and welcome back to module number 8, and in this module we're going to talk about visual correlation analysis. I don't know how many of you know what is correlation analysis. Usually it's a single number that describes the degree of relationship between two numbers or two variables. In this module, I will go through examples and show what they have done, and it will consist not only of two variables, it will consist of multiple variables, and what has visualization help focus on the idea of correlation and what it is. So let's start with the basic. What is correlation analysis definition? It is the idea of the strength of association between two variables, and usually the sort of correlation is measured +1 and -1, and in between is where you see the correlation. So as the correlation coefficient goes towards 0, the correlation is weaker. So the stronger is closer to +1 or -1, it is the strongest correlation. In statistics, we have different type of correlation analysis, and all of them are part of what we are trying to measure and what we are trying to achieve in our correlation. The key characters of correlation is the idea of directions, the strength, and the shape that will come up. In correlation versus regression, we need to identify and to understand that correlation analysis is usually the measurement of the strength of the association, the linear relationship between two variables. In comparison, regression analysis is used to predict the value of the dependent variable based on the value of the least one independent variable, explain the impact changes, and the idea of dependent versus independent are part of the terminology in regression analysis. In comparison to correlation, usually it is not as clear-cut as regression analysis. So correlation coefficient is the measurement of the linear association between variable, and usually we have some idea of what is person production moment correlation as a correlation coefficient. However, we are not in statistics class, we are in visual analytics, and a little bit history about correlation analysis with regard to visual history. And one of the key components of visual correlation was Charles Joseph Mignard. And he worked as a civil engineer in the constructions, and especially in Paris, and was the idea that he used to take the work home and try to generate graphics that represent that. One of the things that he did so well was the idea of capturing the Napoleon attempt to capture Russia campaign in 1812. A little bit about that. Napoleon decided that Russia is weak and he will be able to control Russia by trying to capture Russia, and do that during the worst time of the year, winter. So this is the work of Mignard, and as you can see, there is the idea that's going on that tells you a little bit more storyline with regard to the correlation. It's not the correlation that we are accustomed to see in Excel. Is the idea that in this case we have a lot of visual that plays part in to tell the narrative. Example, the black lines represent the escape of the French army from Russia. And as you can see, Napoleon started the campaign with gray-brown color, and it was had a lot of soldiers. And when he almost got to Moscow, he started to escape, and in the end, he returned to France with a little with little army, and as a result it was a big loss. And so again, the issue of the thick size of the army is a specific element in this visualization, but it also the ability for us to display more about the storyline that goes on into this data. The number of Napoleon's troop, the distance travel, the temperature, the latitude, the long latitude, the direction of the travel, and the location relative to specific dates. All of that is part of Mignard storytelling in the visualization. So it is considered to be one of the top visual analytic in the sense that it shows causality, it captures multivariables, it illustrates text and graph into a coherent whole as going back to our textbook, part of the whole, and it illustrates high quality content, and again complete and accurate data that support the idea of Mignard about the argument against war. And it plays a comparison with one another, trying to capture Russia, the invention of the Russia, and then running back to France, and that's the issue of the idea here. So the idea of showing the efficient differences, bold colors, heavy lines, labels, and scale are part of his Mignard technique to illustrate this idea. Scatter diagram usually display order of pair of measurement that are based on a coordinate system. So we have independent variable that represent in horizontal axis, and the dependent variable that represent y in vertical axis. So the points representing the data is usually plot either a dot or cross. So scatter plot, usually we have height and weight, and usually we come up with something like that. This is a cluster diagram, classic cluster diagram. And that's where we are trying to see correlation between height and weight. And if we learn about a study that shows that the height you are, or the taller you are, the less weight you are, which is not true, but this is part of this idea of what it is. We have in correlation, we have the idea of positive correlation, almost a positive correlation that is +1, or high positive, which is plus 0.9, and even low correlation, which is 0.3. Negative correlation is the opposite, which is almost the perfect -1 score of -1. And so we might have that in that sense. In R, when we have idea of creating correlation, we usually use data frame. Data frame, the idea of data frame is a little bit different from what we are accustomed to see in Excel. Data frame is the ability to capture a lot of variables into one frame or data frame and be able to play with that in order for us to apply or to analyze it. This is the power of our ability to capture several variables into one frame and be able to plot it. In this case, what I did was the df is a data frame. I call data frame, I want you to capture R. I ask R to capture the value of X, the value of Y, and the value of Z, and be able to display it 1 to 3. And so in this case, this is what he did for me in order for me to show the correlation between X, Y, and Z, and this is quite simple analysis. Another methodology with regard to correlation is a function called cogram to visualize data in correlation matrix. And so the idea here is that you start with the establishment of the function itself, the program, and then you are trying to see what variable are you looking at, the X, and the order, and the panel, the lower panel, the upper panel, the text panel, and the dialog panel as a function. So all of it is come to what is the function that you are writing in order to support this type of an analysis. So the result is something like that. You'll be able to display two types of visualization and into one graph, and again to show more variety or to show the insight into the idea of data and what it really means with that regard. Okay, so this is where we come into the second part of our lecture. I started with correlation analysis in R, but the power of R is usually known as the power of ggplot2. This is where the visual analytics in a full swing, it's a full power that allowed us to apply what it is. The author of the package is Handley Wickham, and he is the author, and he also play an important part in RStudio. And idea here is that what he came up in when he started to think about ggplot2 is the idea that he had a framework of how to visualize or take data and convert it into something that it can be converted into R or RStudio. And the idea here is that he was obsessed, like many of us, including myself, with the idea that in order for us to display graphics in a very coherent way that many people will be able to understand, we need to have some form of grammar. We do not have any grammar in visualization. You like red, I like blue, you like circle, I like a triangulation. We do not have vocabulary as we have in language that allowed us to communicate and to share this communication worldwide. So we need to come up with grammar of graphics. So the idea here is that he took another person, Wilkinson, in 2005, come up with the idea of the need or the call for the grammar of graphics. So the grammar of language defines the rule for structuring words and phrases into meaningful expression. The grammar of graphics defines the rule of how we combine mathematics and aesthetic into meaningful graph that allowed us to communicate it to a wider audience. So the idea here that the issue of ggplot2 is based on Wilkinson grammar, and he outlined the following. Any visual grammar or visual graph has to have data, geo, statist, scale, coordinate system, and facing. What is data? Data is the variable that to display in the graph. Variables are mapped to aesthetic and perceived features of the graph. Geometrics is the object or the shape of the graphics, that is the points, the graph. The statistical is the idea of taking the statistical result or a statistical formula and transform it or summarize it into a mean or variance that allowed the R to analyze it and to be able to visualize it. The scale is the idea of having an aesthetic value that are mapped to variables, which is colors that are mapped to which is the values and so on. Then the canvas is the idea of the coordinate system that defines how the data are mapped and the idea of how it maps on a canvas. And phasing is the split of the data to subset to create multiple variation of the same graph. So let's break it down. The data used with ggplot2 is a function that's stored in as a data frame. Everything that we do in ggplot2 is a data frame. We can have multiple data frames that can be used in one plot. So to make sure that we define the variable types before beginning to graph. The aesthetics is quite a little bit a long list. It is the variables that are mapped into aesthetic values, and the function that he came up with is AES, is a function that maps the variable to aesthetic. And so it can be specified inside many ggplot function, example geo, stats, and etc. And the common use of aesthetic is the where is the X position, where is the Y position, what color, what is the fill of the object, what is the alpha, which is the transparency of the object, what is the shape, what is the size, and what is the line type. All of that is part of the aesthetic of the ggplot2. The mapping versus the setting of the aesthetic is part of the code that you're going to write in ggplot2 to map the aesthetic to a dataset variable, specifically inside the asset function. So to set aesthetic constant, again, it will be outside. So setting the aesthetic to a constant inside the function is unexpected sequence. Remember, it is part of the function that inside the ggplot2. So let's break it down. And in this case, this is the correlation between time and protein. And so we are having a diet, and this is what we are having. So how do we map it? How do we create such a visualization? The first of all, we need to call the ggplot2. The ggplot2 is part of a package. You need to insert the ggplot2. If you have already RStudio, it's already embedded. You need to let the RStudio knows that you're going to use its package in order for you to do that. And it will say data. We will say it called milk. The aesthetic will call X is time and G is protein. And then we're going to break it down like a layer into geo points and so on and so on. So the idea here is that we are building up layers of ggplot2 in order to us to visualize it. How many of you are using learn about Adobe Photoshop? Adobe Photoshop, one of its biggest assets is the idea of adding layers to existing image. And so in this case, we are adding layers into R in order for us to make the visual more transparent and based on the visual grammar that was outlined for us. And so the idea here is, again, what we can do in order for us to apply that. I will post the codes later on Canvas, so you will have that. So again, see the difference between the previous and this one with regard to colors. In this case is green. This one is in this case is color is green, but in this case what I did something wrong. Again, something that I did with the code does not reflect what it is supposed to do. Okay, so one of the things that we need to do in order for us to do correlation analysis is the use of ggplot2 and reshape2. It's another package that you need to install. So the data is called attitude, the library is called ggplot2, and the library reshape2. And so in this case, I'm going to call my application gplot, and I'm going to say variance 1, variance 2, data, melt, and I'm going to say correlation, which is the statistical function that I want to apply to the data itself. And I'm going to say what is the attitude and what is the value and what is the title. And so this is the result of it. And again, this is with almost 2 lines. I'll be able to create visualization that Excel does not able to us to produce. I will also post in my in Canvas in module number 8 the data visualization to ggplot2. It is something that the RStudio posted, and as I want you to go over and see how they apply that, I highly recommend that you go over that. Example, they define quite well what is the geo function, what is the mapping, what is the statistic, and what is the position, and they lay out for you what is the graphical ability that you can apply, where you have 2 variables or multiple variables, and the idea of line segments or discrete and all of that. And again, this is a really good layout in order for you to apply. I also will give you more directions of how to do it and give you more ability to understand. And I also recommend you to visit one of the foundation of ggplot2. We as a community wants to share what we know. And in compared to any other society or any other field, this is something that is open for everyone. So first of all, he allowed us to see what it is and give us the foundation of the package itself. And he gave us reference to all the things that we need. Example, the assets. So he breaks down, and you will need to go over that. It is quite interesting to learn about the arguments that you can embed it into the ggplot asset function, what it is, what it entails, and how it be applied. You can actually, what you can do is just copy it straight like that and copy it to your RStudio and run it, and you'll be able to see where is all the functions come into C, and you'll be able to see more example of what it can do and how to apply to it. So this is one example of even basic and so on and so on. I will lay out everything to you, and I hope you enjoy it. I hope you will learn about correlation analysis and what is it entail. Until next time, enjoy.